that hook is either being torn out of the wall or it's not when I apply these forces. If it's not, then it's static, and there's some reactionary force counteracting this resultant force, keeping it in the wall. And we need to take the time to calculate it. Now, if it's static, that means all forces cancel out. So what would be my static force in the x direction to cancel out this? Well, 512.5. What would be my static force in the y direction to counteract this force? Exactly, 90.8. So wouldn't it just go in the opposite direction? The reactionary force would just be going in the opposite direction here to about there, I guess. And it would be what? 512.8 is the x component. I'm sorry, 512.5, and this is 90.8. And so you might say, well, Mr. Anderson, isn't it the exact same thing in the exact opposite direction? Wouldn't we get the exact same magnitude and the exact same angle in the opposite direction? And the answer is yes. And so no, we don't actually have to calculate it. You just have to draw it in the opposite direction. It's parallel to the previous line. It's just going the opposite way. And so what do we get for our reactionary force to make this system static? And I want to be clear here that this RF up here is not reactionary force. This is the resultant force of the two previous. Very important indication there, or sorry, distinction there. So what is our reactionary force? Well, it's going to be the exact same thing as before. It's going to be 520.5 pounds. And it's also going to be 10 degrees. But now it's being measured from the left, from the negative x-axis. So we could say the negative x-axis. And the question is it going clockwise or counterclockwise from that negative x-axis? So we start from the negative x pointing to the left at 9 o'clock, and it rotates back to where it was. What is that, clockwise or counterclockwise? Counterclockwise. That's all a reactionary force would be, equal and opposite. We're done.